So we're going to do, our next lab is called calorimetry. And calorimetry is the study of heat transfer. So what we're going to do is we're going to utilize this principle here. We have two bodies, an unknown, it can be lots of different things, and we always use water to capture the heat. And whether this one is hot or we burn it, what happens is we can take the heat that comes out of this and trap it in the water. Heat is Q. So the magnitude of the heat that leaves substance X is going into the water. So we have a negative sign here to say it's the opposite sign. The amount of heat that leaves X is equal to the heat that goes into the water. Now we're going to assume this assumes 100% heat transfer. We're not going to lose heat to the surroundings or the containers. This is just kind of making this simple assumption. So what do we do with that? We have the water we use because it's easy to measure. There's an equation we can look at where if we know the mass of the water, if we know the specific heat of the water, which is the rate that it absorbs energy by mass, which we'll look at here soon. And we can actually put a thermometer in and measure the temperature change of the water. We know the amount of energy that was in the water. So we kind of backtrace it. We capture all of the heat in the water, which we can calculate, and then we know how much energy came out of substance X. Now there's two things we can do with substance X. The first one is an enthalpy problem. So delta H is a new term that talks about the heat energy in an object. The units on this are kilojoules, usually per mole, or we can say kilojoules per gram sometimes if we have an unknown. And this is a heat term. So it's Q over the moles. So if we know the heat of the water, we can backtrace that to substance X and then maybe calculate this enthalpy term, which is a property of our unknown. So this is one lab that we're going to do. This is actually the first one we're going to do. We're going to do a second lab. What else can we do with this? Well, if we know the heat of substance X, we can analyze it. We could measure the mass. We could analyze and say, hey, what's the specific heat of that substance also? And we can measure temperature changes of that substance sometimes, depending on the context. So that allows us to actually figure out some properties of substance X as well, including specific heat, because we're backtracing it through the water. So if we know how much energy is in the water, then we know how much energy went into X, and we can do one of these two things with it. And this is how we study calorimetry, the energy transfer between a substance and water, to calculate and define some of its properties.